next topic. Next topic is coordinates and coordinate vector. So definition, let capital V be a vector space, and then capital V is equal to V1, V2, Vn bar, right? Either bar or without bar. V1 bar, V2 bar, Vn bar. V1, V2, Vn be its basis, and V is the, and this V bar belongs to this capital V, is the element of this vector space V. And then we know that this is basis of vector space V, means this set spans vector space V, and means every vector of V can be expressed as a linear combination of V1, V2, Vn. So if this V bar expressed like this, K1, V1 plus K2, V2 plus Kn, Vn. Then these K1, K2, Kn are the scalars, where these K1, K2, K3 are Kn are scalars. So this is basis, means every vector of this vector space V expressed as a linear combination of V1, V2, Vn. This is possible for every vector, and these K1, K2, Kn are scalars. We have some scalars. Then these K1, K2, Kn are called coordinates of V bar with respect to the basis B. Okay, these K1, K2, Kn are called coordinates of V bar, this vector V bar, with respect to or in or relative to, we can say with respect to basis B, or we can say relative to the basis B. And if you write this K1, K2, K3 in round bracket, that is in round bracket, write K1, comma K2, comma dash Kn, and we denote this as by this notation in round bracket, write V bar, and at the bottom write this capital B, this basis B. So this is the notation for coordinate vector of V bar relative to the basis B, or with respect to the basis B. So this is the coordinate vector of V bar with respect to basis B. So this is the notation, and this is the answer. Actually, in round bracket, write K1, K2, dash Kn sequentially, and it's called coordinate vector of V bar relative to the basis B, or with respect to the basis B. So in order to find the coordinates and coordinate vector of any vector from the vector space V, we have to express that vector as a linear combination of V1, V2, Vn as the elements of basis. So it is the repetition of the topic linear combination. This is the linear combination base. Totally this topic depend on the linear combination, but this is important as far as the exam concerned. This topic is important. So the straightforward question, find the coordinates and coordinate vector of this 1, 2, 3 relative to the basis 1, 1, 1, 0, 1, 1 and 0, 1, minus 1. That is, all these are the elements of R3, and we have to find the coordinates of this 1, 2, 3 with respect to this basis. So we denote this 1, 2, 3 as a V bar, and this vector as V1, V2, V3. Okay, and now we have to express this V bar as a linear combination of V1, V2, V3. So let K1, K2, K3 be scalars such that V bar is equal to K1, V1 plus K2, V2 plus K3, V3. So this is the first sentence. Let K1, K2, K3 be scalars such that V bar is equal to K1, V1 plus K2, V2 plus K3, V3. And then substitute V bar as 1, 2, 3, then V1 bar, V2 bar and V3 bar. And then apply the definition of scalar multiplication and vector addition. That is, solve this, simplify this right side. So write is equal to K1, comma K1, comma K1 plus 0, comma K2, comma K2 plus 0 minus K3, K3, and then add the respective sides. Okay, so we have the add the components. We have the system. Compare with the is equal to 1, 1, 2, 3. Okay, so that is, we have the 3 equations and 3 unknowns. So what are that equation? K1 is equal to 1. K1 is equal to 1, and the second equation is K1 plus K2 minus K3 is equal to 2, and the third equation is K1 plus K2 plus K3 is equal to 3. So we have to solve that system. Here is the answer, correct answer. Ignore this. So the same question, and so we have to first write the sentence that K1, K2, K3 be scalars such that V bar is K1, V1 plus K2, V2 plus K3, V3, and then write V bar, V1 bar, V2 bar. Then apply the definition of scalar multiplication and vector addition. So write two more step here. So write is equal to in round bracket k1 comma 2k2 comma 3k3 minus 3k3. This is another example. Actually, this is another example. So same method apply here. So we find the values of k1, k2, k3, and I think the values are 1, 3 by 2 and minus 1 half. These are the values of k1, k2, k3. So 1, 3 by 2 minus 1 by 2 are coordinates of v bar, and the coordinate vector of v bar relative to the basis b is what? V bar in round bracket, right? V bar at the bottom b is equal to, right? This is in the round bracket, that is open bracket 1 comma 3 by 2 comma minus 1 half. This is the coordinate vector of v bar, and these 1, 3 by 2 and minus 1 half are coordinates of v bar. So same here the we apply the same procedure. We have the system and solve that system and find the values of k1, k2, k3. Okay. So here the answer. So write two more step here is equal to k1 plus 2 k1 in round bracket, right, is equal to in round bracket k1 comma 2k1 minus 3k1 plus similarly in round bracket k2 minus 3k2 2k2, and in round bracket 2k3 minus k3 comma 5k3, and then add the respective sides. So we have in round bracket here, round bracket in the round bracket k1 plus k2 plus 2k3 comma 2k1 minus 3k2 minus k3 comma 3 minus 3k1 plus 2k2 plus 5k3 round in the bracket, and then compare the LHS and RHS here, right? Bracket here, open bracket, and then compare the LHS and RHS. We have k1 plus k2 plus 2k3 is 1. This is equal to 2 and this is equal to 3. And we have the system. We have to solve this system. Similar example here, apply the same procedure. We have the system and solve that system by using Gauss elimination method. We have the values of k1, k2, k3 as 1, 3 by 2 and minus 1 half. So here the we have to write we have to solve this system, non-homogeneous system. So we have to write augmented matrix. So write augmented matrix 1, 1, 2, 1, 2 minus 3 minus 1, 2, and 3, 2, 5, 3. Okay. So this is the augmented matrix, the combination of A and matrix of constant B. So this is the augmented matrix, and we have to reduce this matrix to echelon form. So here is 1. So we have to reduce this 2 and minus 3 as 0. So the application are R2 minus 2 R1, R3 plus 3 R1. We have this, and then minus 1 by 5 R2. We have to reduce this minus 5 to 1. So we have this, and then we have to reduce this 5 to 0. So R3 minus 5 R2. We have this is the last row. Then we have to reduce this 6 to 1. So 1 by 6 R3. So we have this, and this is an echelon form. So rewrite the equation. So what is the first equation? K1 plus K2 plus 2K3 is equal to 1. Write that K1 plus K2 plus 2K3 is equal to 1. The second equation is K2 plus K3 is equal to 0. And the last equation is K3 is equal to 1. And so if you find K3 is equal to 1, substitute in the second equation, we have K2 is minus 1 and both the values in the last equation. So we have K1 is 0. And therefore the coordinates of the given vector are coordinates. So don't write this round bracket 0, comma, minus 1, 1. These are the coordinates. Don't write round bracket. And the coordinate vector of V bar with relative to the basis B, that is right in round bracket V bar at bottom B is equal to now write the this open bracket 0, comma, minus 1, comma, 1. So these are the coordinates, coordinate vector, okay, in round bracket. So don't write here round bracket, just write 0, minus 1, 1 are the coordinates. So in order to find the coordinate and coordinate vectors, we have to express the element as a linear combination of the elements of the basis. So find the coordinate and coordinate vector of this vector relative to this basis. Now we have to reduce this element to as a linear combination of these, and this is the standard basis. So very easily we can reduce this this as a linear combination of this. So 2 minus 1, 3 minus 4 is 2 into 1, 0, 0, minus 1 into 0, 1, 0, 0, 3 into 0, 0, 1, 0, and 4 into 0, 0, 1. And therefore the coordinates of this vector 2 minus 1, 3 minus 4 are 2 minus 1, 3, 4. These are 3 minus 4. These are the coordinates. And coordinate vector is what? in a round bracket 2 comma minus 1 comma 3 comma minus 4. This is the coordinate vector. So find the coordinates and coordinate vector of this relative to this basis. So in order to find these coordinate of this vector, coordinates and coordinate vector of this vector relative to this basis, we have to reduce this vector as a linear combination of these. So in this way, we cannot find directly the answer of this k1, k2, k3, k4. So we have to denote this as a v bar. This is v1 bar, v2 bar, v3 bar, v4 bar, and then write the sentence that k1, k2, k3 be scalar such that v bar is equal to k1 v1 plus k2 v2 plus k3 v3 plus k4 v4. Substitute the values of v bar, v1 bar, v2 bar, v3 bar, v4 bar, and then apply the definition of scalar multiplication and vector addition and express this element as a linear combination, and find the values of k1, k2, k3, k4. So we have the coordinate and coordinate vectors. So find the coordinate and coordinate vector of this relative to the basis 1x x square. So we have to reduce this 3 minus 2x plus 4x square as a linear combination of this. So we can write 3 as 3 into 1, and then minus 2x, okay, minus 2x, and then 4x square. So just write this as a linear combination of 1x and x square, and therefore 3, the coordinates are 3 minus 2, 4 are the coordinate, and coordinate vector is what? Right in round bracket 3 comma minus 2 4. This is the coordinate vector of this vector 3 minus 2x plus 4x square relative to the given basis. So find the coordinate and coordinate vector of this relative to the basis x, 3x square, 5 plus x. So where to write this 3 minus 2x plus 4x square as a linear combination of these. So we can write 3x square, this as a linear combination of these three vector x, 3x square, 5 plus 4x. So write k1, k2, k3. So write k1 x plus k2 3x square plus k3 5 plus x, and then solve the simplify the RHS and compare LHS and RHS and find the values of k1, k2, k3. We have the value of k1 as 3, k2 as minus 2, and k3 as 4. So don't write directly 3, this minus 2, and this is wrong answer. So what we have to do, let the first sentence is let k1, k2, k3 be scalar such that this 3 minus 2x plus 4x square is equal to k1 into x plus k2 into 3x square plus k3 into 5 plus x, and then find the values of k1, k2, k3 by solving. So this is about the w1 and w2 are subspaces. Then w1 plus w2 is also subspace. Is called sum of these w1 and w2. This is the example on the previous topic. So what is w1 plus w2? w1 bar plus w2 bar. w1 bar comes from w1 and w2 bar comes from w2. And then we have to show this is the subspace of w. So the addition of two subspaces is again subspace, or sum of two subspaces is subspace. So obviously this is not equal to phi, and this is subset of v. We have to show two conditions. Let u bar and v bar be two elements of w1 plus w2, u1 bar, u2 bar, v bar as v1 bar, v2 bar. Obviously this u1 and v1 comes from this w1, and u2 and v2 comes from w2, and then their addition is this again is the element of w1 plus w2, and therefore w1 plus w2 is closed for addition. Similarly, take a w1 plus w2 as the element of w1 plus w2, and kb in is scalar, their multiplication is this again is the element of w1 plus w2, and therefore it is closed for w addition of scalar multiplication. So this is the previous topic, and so it is subspace. The sum of w1 and w2 is called sum of w1 and w2. w1 plus w2 is called sum, and uh, direct sum, if he is w1 plus w2 and w1 intersection w2 is empty, is empty set, then we say that only 0 is the common element in w1 and w2. Then we say w1 and w2 as a direct sum, v as a direct sum of w1 and w2. So the direct sum is also the subspace. So these are the examples on the subspace topic. So this is about the coordinate and coordinate vectors. The topic coordinate and coordinate vector. So some exercise on this topic, coordinate and coordinate vector. Exercises on the topic coordinate and coordinate vector. So the question is what? Show that this is a subspace. Already these are examples are solved in previous lecture. So find the coordinate of m as 2 minus 3 minus 4 minus 5 relative to the above basis, that is this basis. So this is the standard basis m1 m2 m3 m4. So just to add to express this 2 minus 3 4 minus 5 as a linear combination of these four vectors, and therefore what are that? 2 into m1 plus minus 3 into m2 plus 4 into m3 minus 5 into m2, and therefore 2 minus 3 4 5 4 minus 5, this in round bracket, this is the coordinate vector of m, this vector relative to the basis b. So write this is the notation, write in round bracket m, at the bottom b, in round bracket 2 comma minus 3 4 5. So this is the basis 1 x x square x raised to n is the basis for pn, space pn, set of all polynomials of degree less than or equal to n. Then find the coordinate. This is the first question, that is its answer is given. So we have to find the coordinate vector of this polynomial relative to the basis this. That is, we have to reduce this p as a linear combination of x cube x square x and 1. So see the answer. So p is this a3 x cube a2 x square plus a1 x plus a ton. So we can write that it is as a linear combination of this uh, as a3 x cube as the linear combination of these three vectors p. What is p? P is this a naught plus a1 x plus a2 x square plus a3 x cube. So we can write as a linear combination. So write just change the places, a3 x cube a2 x square a1 x plus a naught into 1. So this p written in this fashion. So it is a linear combination of the vectors in this x cube x square x and 1, x cube x square x and 1, and therefore a3 comma a2 comma a1 comma a naught are coordinates of p, and the coordinate vector is what? Of this p. So write in round bracket p at the bottom, b is equal to, in round bracket write a3 comma a2 comma a1 comma a0. Okay, so write, this is the sequence is important. So this is the coordinate. So find the coordinate of this 1 2 relative to this basis 3 2 1 minus 3. So we have to reduce this 1 2 as a linear combination of these two vectors. So let k1 and k2 be scalars such that u bar is k1 u1 plus k2 u2. So substitute the values of u bar u1 u2 and find the values of k1 and k2. We have these are the values of k1 and k2, and therefore coordinate vector of u bar is this, right, in round bracket 5 by 13 comma minus 2 by 13, and these 5 by 13 comma minus 2 by 13 are called coordinates of u bar. So same example is the second example, 1 2 3 as a linear combination of these three vectors in order to find relative coordinate and coordinate vector. So express this vector as a linear combination of these three vectors. So apply the procedure. So we have the answer, this 3 2 and 1. These are the coefficients 3 2 and 1. In order to verify, we have to calculate this. Don't write these two steps. So express u bar as a linear combination of u1 u2 u3. So 3 2 1 are the values of k1 k2 k3 after solving the system. Don't use this method. In order to solve this system, apply the Gauss elimination method. Just find the form the augmented matrix and reduce the matrix to echelon form. Don't follow this procedure. So we have the k1 is 0, the values of k1 k2 k3. So we have k1 is 0, k2 is we have the value of k1 is 0, k1 is k2 is minus 1, and k3 is 1, and therefore the coordinates of 1 2 3 relative to the basis b are 0 minus 1 1, 0 minus 1 1, and coordinate vector is this 0 in round bracket 0 comma minus 1 comma 1. So this is the coordinate vector. Okay, and these are coordinates. So in order to relative to the basis, also find the coordinate relative to this basis. Okay, so the 1 2 minus 3 and okay, so this is the answer. And if there is another basis, then there is another element, suppose 7 minus 1 10 as the element, then we can also find its uh, coordinate and coordinate vectors related to the same basis. Another vector is what? 7. This is another problem from this step. So this is the answer of the problem. So write in the note form, that is the coordinate of and coordinate vector of 7 minus 1 10. So we express 7 minus 10 as a linear combination. So we have the values of k1 k2 as 3 2 1, and so the coordinate the coordinate vector of this 7 minus 1 10 is this 3 2 1, and these 3 to 1 are the coordinates of 7 minus 1 10. So these are the examples for exercise. Find the uh, coordinate vector of this relative to this basis, these four elements. So we have to express this as a linear combination of these four vectors. So same example, we have to find the coordinate of this A with respect to these four. So same example on R3. So this is the repetition of the topic. The answer is given. So answer are also given. So this is the repetition of the topic, linear combination. Where to find, in order to find the coordinate and coordinate vectors, where to express the vector as a linear combination of the vectors, remaining vectors. Here we have to express u bar as a linear combination of v1, v2, v3. So answer of 8. 3 minus 1 are the values of k1 k2 k3. So in this is the coordinate vector. This is the answer of the second problem, where to express u bar as a linear combination of v1 v2 v3. So what is the first sentence? Let k1 k2 k3 be scalar such that u bar is equal to k1 v1 plus k2 v2 plus k3 v3, and then substitute the values of u bar, v1 bar, v2 bar, v3 bar, and find the values of k1 k2 k3. So answers are given. So this is about the topic coordinate and coordinate vector. So we'll see the next topic in the next lecture.